A fluid in a cylinder at a pressure of 500 kilonewton per meter square is expanded at a constant pressure from a volume of 0.5 meter cube to a volume of what? To a volume of 1.56 meter cube. So we have to calculate the work done. So you have to take note that the general formula for the constant pressure process, which is the work done, is the same thing as work, the pressure multiplied by delta V. Delta V is the same thing as what? As change in volume. Delta V is the same thing as V2 minus what? V2 minus B1. So the next thing that I'm going to do, this is what? This is the value of what? Of the pressure. And this is what? This is the V2, and this is what? This is our V1. So I have to subtract what? I have to say this should now be equal to the value of B2, which is what? 1.56, and subtract by 0.5. So this should now be equal to the work done, which is equal to the pressure, which is 500 multiplied by, what will be the solution of this? If I say 1.56 minus 0.5 is the same thing as what? 1.06. So multiplied by 1.06, and the work done should now be equals to 500 and what? 530 kilonewton meter. But you have to notice that 1 kilonewton meter is the same thing as 1 kilojoule. So therefore I have to say this is the same thing as saying 530 kilojoules. So this is the final solution to this question. And the formula that you might use is work done, which is equals to the pressure multiplied by what? Multiplied by change in what? Change in V. So now let's move to the second question. So the second question also says a fluid in a cylinder is at pressure of what? Pressure of 700 kilonewton per meter square. It is expanded at constant pressure from the volume of what? Which is V1 0.28 and V2, which is 1.68. We are to determine the work done. So work done is the same thing as what? Phi delta V, which is the same thing as pressure, which is 700 multiplied by delta V, as I said, is the same thing as what? V2 minus V1. So the value of V2, which is 1.68 minus what? Minus 0.28, and automatically equals to 1.40. So multiply by 1.40, and it will give us 900 and what? 980. So the answer, which is 900 and what? And 80 kilonewton meter. But as I said, 1 kilonewton meter is the same thing as what? 1 kilowatt, 1 kilojoule. So therefore the final solution should now be equals to what? The work done will be equals to 900 and what? And 80 kilojoule. So this is a solution of what? Of the second question. So the third question, 5 kg. So this is 5 kg. 5 kg of steel. So therefore I have to say mass, which is what? 5 kg. And the specific heat capacity, which is C, is the same thing as what? 450. Is heated from what? From the temperature 1, which is 15 degrees, and therefore the T2, the temperature 2, which is the same thing as 100 degrees Celsius. So we are to determine the rate of what? Of heat. So the rate of heat transfer, which is Q, is the same thing as the general formula, which is MC delta T. So you have to take note that delta T is the same thing as what? Is the same thing as T2 minus T1, which is the same thing as 100 minus what? Minus 15, which is equals to what? Which is equals to 85 degrees Celsius. So I have to substitute. The value of Q should now be equals to M, which is 5, multiplied by C, which is 400 and what? And 50, and multiplied by what? Multiplied by 85. So what should I going to get? Let me delete this. So therefore the value of Q should now be equals to what? 19125 what? 0 joule, and this is the same thing as saying 0.25 but kilojoule. So this is a solution in kilojoule. A process was carried out in what? In a closed system, where 1500 kilojoule was what? Was transferred into the system, and 400 kilojoule of work was transferred from the system. Determine the change in total energy and state whether it is an increase or decrease. So you have to take note that in what? In a closed what? In a closed system. And for a closed loop system, the value of Q minus what? Minus W, capital W, and also it is equals to what? E2 minus what? Minus E1. And the heat transfer into the system, which is Q, it is given by what? It is given as positive 15 what? Kilojoule. And also the work transfer from what? From that system, it is also given as what? Positive what? 400 what? Kilojoule. Sorry, this is what? This is 400. And the next thing you have to take note that this is the same thing as saying E2 minus what? Minus E1 is the same thing as Q minus W. And the values that we are given the value of this Q, which is 1500. So I have to say this should now be equals to the E2 minus E1 is the same thing as 1500 minus what? Minus 400. So this is the same thing as 1100 what? Kilojoule. So this is the final answer. So this 1100 kilojoule, it is what? Increase. It increase in what? In total energy. It increase in total energy. So therefore this is what? This is the final solution to this first question. So let's see the third question. And you have to take note that the value of E2 minus E1, they are what? They are the closed loop that we are looking for. The second question, in a process carried out on a closed what? On a closed system, also on a closed system. So the total transferred into the system was what? Was 4200 kilojoule, and the increase in the total energy of the system was what? 3500 kilojoule. So we have to determine the heat transfer and state the direction of what? Of the transfer. So also we are going to use the formula that says the Q minus W is the same thing as what? E2 minus what? Minus E1. And therefore the work, it says the work transfer into the system was, so the work transfer into the system, so it has to be negative. So therefore we have kilojoule. And the next thing, and you have to take note that the reason why I put this negative is that the work done is on the system, and therefore the increase in what? Increase in energy, which is E2 minus E1, is the same thing as what? Positive 3,500 watts kilojoule, which is the increase in total energy. And the next thing that I'm going to, I have to substitute to this what? To this formula. So I will say Q minus what? Open bracket minus 4200 close bracket. It will now be equals to what? The increase in total energy, which is E2 minus E1, and it is the same thing as what? 3500. So this should now turn to plus because all are negative. So Q plus 4200, it will now be equals to 3500. The next thing that I'm going to do, I have to make the Q subject of the formula. So to make this Q subject of the formula, I will say Q, it will now be equals to this 3500, it will stay, and the positive 4200, the positive 4200 will now cross the equal sign, it will now be negative. So I have to say what? Minus 4200. So therefore the Q should now be equals to negative 700 kilojoule as the what? As the final solution. So the next question says determine the heat transfer. Okay, sorry, it says determine heat transfer. So next question says state the direction of the transfer. So the direction of what? Of this transfer is what? Negative sign. It means heat is rejected from what? From the system. So therefore it is negative sign. It is showing that heat is rejected from what? From the system. 0.5 meter cube of gas at pressure of what? At the pressure of 150 kilonewton per meter cube was compressed to 850 kilonewton per meter cube. According to the law, PB raised to the power of 1 minus 4, it is equals to C. Calculate the new volume of what? Of the gas. So you have to take note that for a polytropic process, B1 raised to the power of N is the same thing as what? As P2 what? B2 raised to the power of N. So we are going to substitute to this formula and what? And calculate the new volume of what? Of that gas. You have to take note that the value of P1, it is this. It is this 150 kilonewton. Take note of that. This is P1. And you have to take note of B1. This is B1, 0.5. And you have to take note of P2. P2, this is 850 watts kilonewton per meter. And you have to take note of the value of N, which is this power 1.4. PB raised to the power of 1.4 is the value of what? Of N. So I have to apply what? The formula. The value of P, which is this 150. So I have to say 150 multiplied by what? By value of B1. What will be the value of B1? So the value of B1, which is 0.5 raised to the power of N, which is 1.4, and it is the same thing as the value of P2. The value of P2, which is this 800 and what? 850. And don't forget, I'm looking for it, which is V2 raised to the power of what? Power of N. Yes. So the next thing that I'm going to do is that if I said 0.5 raised to the power of 1.4 and also multiplied by 150 is the same thing as 56.835, which is the same thing as 800 and what? And 50 v2 to the power of what? Of 1.4. So you have to take note that the value of this n is the same thing as what? 1.4. So the next thing that I'm going to do, I have to divide both sides by what? I have to divide both sides by 800 and what? And 50. 800 and what? And 50. This will go with this. At the end, b to the 1.4 power 1.4 is the same thing as 56.835 divided by 850. It will now be equals to 0.06686. So the next thing that I'm going to do, I have to take 1 of 1.4 to both sides. If I take also 1 over 1.4, so this 1.4 will go with this 1.4. At the end, it is only v here, and also right hand side I will have 0.06686 to the power of 1 what? To the power of 1 over 1.4. So let me have some space. B should now be equals to, if I press in the calculator and say 0.06686 to the power of 1 by 1.4 in power, so at the end the second v2 should now be equals to what? 0.145 meter cube. So this will be the value of what? The value of B2. Also the next question says 0.11 meter cube of a gas has pressure. So this is the first pressure, which is 138. It is compressed to 690 kilonewton per meter square. According to the law of Phoebe to the power of 1.4 is equal to C. So we have to calculate the what? The new volume. The same procedure, P1, B1 raised to the power of what? N is the same thing as P2, B2 raised to the power of what? Raised to the power of N. So the value of P1, which is the same thing as what? Which is the same thing as 138. So 138 multiplied by the value of B1, which is 0.112 from the question, power of 1.4, which is equals to P2, which is 690. This is the value of what? Of P2, and multiplied by the value of V2, which is power of 1.4 also. So if I multiply this, what should I going to get? So complete, if I multiply this, I'll get 6.4584, which should now be equals to 690 B2 1.4. So I have to divide both sides by 690. 690, this will go with this. At the end, I will now say the value of B2. Let me have space. So the value of B2 to the power of 1.4 is the same thing as, if I say 6.4584 divided by 690, what should I going to get? So at the end, I will get what? I'll get 0.00936. So if I take both sides of 1.4, also take 1 over 1.4. So this 1.4 will go with this. At the end, I will end with only V2. So if I press this in calculator, I'll get 0.036 meter cube. So this is the value of what? Of the volume that we are asked to calculate. We are asked to calculate what? The new volume of what? Of the gas. So let's move to the third question. Determine the work done during what? During expansion of 0.014 meter cube of a gas from a pressure of 2070 kilonewton per meter to 207 according to the law. So you have to take note that the formula of the work that we are going to is for the polytropic. So the work should now be equals to P2 B2 minus P1 B1 divided by 1 minus N. So this is a formula. This is 1 minus N. So you have to take note that this is the first volume and this is the first pressure and this is the second pressure. So we are looking for what? For the second volume. So to find this, we have to first identify the value of this V2 to find the value of work. So using this formula that says P1 B1 power N is the same thing as P2 B2 power N. We have to substitute and say P1 is the same thing as 2070 multiplied by 0.014 per 1.35. It is equals to the value of P2, which is 207 B2 power 1.35. So if I multiply this and divide both sides by what? By 207. At the end, 207 will go with 207. Also, our divide is by 207. But I have to first multiply this numerator and divide it by 207. So if I did that, I will get what? I will get 0. Let me press it here. 0.2259. It is equals to what? V2 power 1.35. So I have to take both sides of 1 over 1.35. So at the end, I will left with only V2. You have to take note that this 0.2259, I will take the power of 1 over 1.35 at this point, and therefore I'll get my V2, which is 0.332 meter cube. So this is the value of what? Of V2. So then I have to substitute to this formula, then I will be able to find the value of what? Of the work done. So I hope you know how to find the value of this V2, guys. So work done should now be equals to, I have to say 207, which is P2 multiplied by 0.332 as our V2 that we find, and therefore minus 2070 multiplied by 0.014. So then I have to divide by 1 minus the value of N, which is 1.35. So let me press it and see what should I going to get. So the value of this work done, so the value of the work done should now be equals to minus 113.55 what? Kilojoule. But this negative sign, it indicates the expansion work by what? By the gas. The negative sign indicates expansion of work by the gas. So therefore the final answer, work, should now be equals to 113.6 kilojoule. A power station has an output of what? 800 megawatt and the thermal efficiency of 28 per second. We are to determine the coal consumed in ton per hour if the calorific value of the coal is 31 megajoule per kg. So we have to notice that the thermal efficiency, which is the same thing as what? W by what? By Q. So you have to take note that we are looking for the value of what? Of Q. So by cross multiply, I will have what? Q multiplied by the thermal efficiency, which is equals to W, which is the work. So I have to divide both sides by what? By the thermal efficiency, and thermal efficiency will go with thermal efficiency. At the end, Q, it is equals to work by the thermal efficiency. And the work, what will be the work? The work, which is the output power. W is what? Is the output power. So therefore I have to say the output power is the same thing as what? 800, and also divided by the thermal efficiency, which is 20 what? Which is 28%, but I have to convert it. It will now be 0.28. So at the end, Q should now be equals to 2857.14 what? Megawatt. So this is the value of what? This is the value of what? Of the Q. And you have to take note that the final coal, and we have to find the coal consumption what? Rate. But let me have some space. So the coal consumption rate that I have to find, determine the coal consumed in what? In ton per hour. So I have to first find the coal consumed, which is the same thing as the value of what? As the value of base Q that I already find, which is 2857.14 divided by what? Divided by 31. So 31, which is the calorific what? Which is calorific value of what? Of coal. So at the end, this should now be equals to 92.17 what? Kg per second. But you have to take note that it says convert to ton per watt, to ton per hour. So I have to convert it to what? I have to convert it to ton per hour. So I have to say 92.17 92.97 multiplied by, if I multiplied, I will get 331.812 kg per hour. So at the end, this is the same thing as saying 331.8, then I will say ton per hour. So as you can see, the 331.812 kg per hour, it's now turned to 331.8 because the kg now turns to what? So therefore 31118. So therefore the value of what? The value of 331,812 kg per hour is the same thing as 331.8 ton per watt per hour. So now this is what? This is the final solution to the first question. A steam plant uses what? uses 3.045 ton of what? Of coal per hour. So the steam generated is fed to a turbine whose output is 4.1 megawatt if the calorific value of the coal is 28 megajoule per kg. So determine the thermal efficiency of the plant. So you have to take note of this formula. This should now be equals to work divided by what? By Q. And don't forget we are given the coal. This is the coal. The steam plant uses 3.045 ton of coal per watt per hour. So this 3.04 what ton of coal per hour is the same thing as 30.45. Don't forget I have 5 here. 45 kg per watt per hour, as I did in what? In the first question. So this is the same thing as what? As this. And don't forget I have what? I have the value of what? CB, which is the calorific value of what? Of 28 megajoule per kg. So this is the calorific value, and I have the output, which is 4.1 megawatts. So you have to what? You have to take note of these values. Those are what? Are the datas. So the next thing that I'm going to do is that I have to first convert the coal rate to what? To kg. The coal rate should now be equals to 3045 divided by 3600. So if I calculate it, I will end off with 0.8458 what? Kg per second. So as you can see, I convert the coal rate to kg per watt per second. So then step 2 is what? The heat supplied. So the heat supplied, so let me do like this. So the heat supplied Q, it should now be equals to 0. What? The answer that I get in kg per second, which is 0.8458 multiplied by what? By 28, which is a calorific value, which is 28. So at the end, Q should now be equals to what? 23.68 megawatts. So the next thing is the efficiency. So what will be the efficiency? As you can see, I can't be able to find the value of this efficiency unless I'll find the value of what? The value of this Q. So you have to take note that this 3045, you have to first convert it to kg per second by dividing it by 3600, and therefore find the value of Q, which is the value that you convert multiplied by what? By 28, which is the calorific value, and therefore substitute. So for now I have to substitute. Then I will say the value of work, which is the power, which is 4.1 divided by 23.6 what? 68. So this should now be equals to 0.173. So at the end, the thermal efficiency, it is 17.3 what? percent. So this is the solution to the second question. So let's move to the next question. A petrol engine uses 20.4 kg of petrol per hour. of a calorific value. So this is a calorific value of 43 megajoule per kg. The thermal efficiency, which is 20%, determine the power output. So we are to determine the power output, but don't forget we must use the thermal efficiency formula, which says W, which is the output divided by by Q. And don't forget, we already have the fuel used. The fuel used, which is this 20.4 kg, and the calorific value, which is 43, and the efficiency, which is what? Which is 20. So the next thing that I'm going to do, I have to convert the fuel consumption to kg per second, as I did before. So M should now be equals to the 20.4 by what? By 3600, which should now be equals to 0.00567 kg per second. So after then, Q should now be equals to, I will be able to find Q. I will write what I already find, which is 0.0567. So I have to say multiplied by 43, which is what? The calorific value. So at the end, the Q should now be equals to what? Q should now be equals to 0.2438 megawatts. So this is the value of what? Of the Q. And the next thing to do is the power output. So you have to take note that the power output, from this I have to cross multiply. If I cross multiply, the output should now be equals to the efficiency, thermal efficiency, multiplied by Q. So this is now the same thing as, what is the thermal efficiency, which is 20. So I have to convert it. It will now be 0.20 multiplied by the Q, the answer that I get, which is 0.2438. At the end, the power output, it is now equals to 0.04876 megawatt. So this is 8, and therefore it says, after determining the power output of engine and the energy rejected per minute, also we are asked to find what? The energy that is rejected per what? Per minute. Let's say Q is what? The energy, let me say R, rejected, is the same thing as what? Q minus what? Minus W. As you can see, this should now be equals to the value of Q, which is 0.2438 minus what? 0.04876. So this should now be equal to 0.19504 megawatts. So the energy rejected per minute is the same thing as multiplying this by what? By 60. So at the end, the energy rejected per minute should now be equals to, let me say equals to 11.70 what? Megajoule per minute. So this is what? Energy what? This is the energy. It comes at a speed of 30 kilometers per hour against a resistance of 500 Newton. Determine the power output of the engine of the car at this speed, neglecting all losses. So we are to determine the power output. But to determine the power output, we have to recall one of the formula of mechanical power that says P is the same thing as what? The force multiplied by what? By the speed. So, as we all know, the value of what? Of the force, which is 500 what? Newton. So, given the resistance force as 500 Newton and the speed, which is what? The speed, which is 30 kilometer per hour. So I have to convert this to meter per second because it is speed. So this is the same thing as saying I have 30 per hour, which is 300. Okay, sorry, 3,600. So if I divide this, but I have kilo, so I have to multiply it by what? By 1,000 to make the conversion correct. So at the end I'll get 8.33 meter per second as what? As my new speed. So this is the same thing as saying the power, which is 500 multiplied by 8.33. The final answer should now be equals to what? The power, which should now be equals to, let me say, 500 multiplied by 8.33. So at the end I'll get 416 what? 65 watt. 4,165 as the final answer of what? Of the first question. So let's move to the next question. The output of a power plant is 500 megawatts, which represents 28% of the energy put into the plant by burning coal in the boilers. If the coal has the calorific value of 29.5 megajoule per kg, determine the mass of the coal burned by what? By the power station in 1 hour. So don't forget with the general formula of the thermal that says work, which is the power output divided by what? By Q. So as we are given the power output, the output power, and also the efficiency, everything is given, and the same with the calorific value as what? This is the calorific value. So the next thing that I'm going to do, I have to first determine what? The heat input. The heat input, which is I'm going to make Q subject of the formula. So at the end, Q, the thermal, which will be equals to W. So if I divide both sides by what? By the thermal efficiency, at the end Q should now be equals to the output, which is 500 divided by the thermal, which is 0.28, and at the end I will get this 1785.71 megawatts as what? At the value of Q. So I have to, the next thing that I have to determine the mass flow rate of what? Of coal. So the mass flow rate of coal, I will just going to divide the answer by what? By 29.5, which is a calorific what? Calorific value. So at the end, the mass of the flow rate of that coal 60.5 what? 3 kg per watt per second. So I have to convert it to what? To kg per hour, because this is in what? Kg per watt per second. But I need some space. So I have to say the 60.53, I have to multiply it by what? By 360 0. So this should now be equals to what? 217,908 kg per hour. So as you can see, the same thing, I have to convert it to ton per hour again, but to convert it to ton per hour, I will just pick at least 3 digits. Let me have some space. I have to just pick 217, then I have to put point and put 9, and then I will now put ton per hour. So this is the final solution to this question. So this is all I have for you. Don't forget to subscribe to this YouTube channel if this video is more helpful to you. Don't forget to share to your learning colleagues. Thanks you for watching. Do have a nice day.